To change the timing belt, we need to remove this big pulley here, or counterbalance actually, counterbalance for the crankshaft. And to do that, we need to remove this big 41mm bolt. And to do that, we need to block the crankshaft. To lock the crankshaft, what we have to do, screw a bolt into there, that engages in that slot you can see there on the flywheel. So again, I can point this slot here. So I'm not going to buy a special tool, but what I have found is an old wheel bolt with a cracked thread to fit into this hole. So if you can see it, I can screw it into the hole. What I'll do in a moment, I'll measure the thread, then you'll know exactly what thread you need. So that fits in there. I measured it with a micrometer. It is 14mm in outside diameter, and measuring with a ruler as closely as I can. The thread pitch is 1.5, so I'm fairly sure it's an M14 by 1.5 pitch thread. And just to help us prove that, I've actually seen on the end it's grade 8.8, which definitely means it's a metric bolt. So I'm fairly sure it's a M14 the 1.5mm pitch thread. So we'll measure the slot in the flywheel there. It's a bit hard to get my ruler in there, but it's around 6mm. So the slot is about 4mm deep, and it's approximately 14mm from the edge of the thread. So my original plan was to grind down the end of the bolt so it fitted into that slot there, but since you realised that there's not quite enough thread on the bolt, it's about 5 or 6mm short of being long enough. So what I'm going to have to do is weld a little extension onto the end of this bolt. I mean, hopefully yourselves you can find a bolt that's a little bit longer, and you can just grind the end of the bolt down to 6mm in diameter so it fits straight into the hole. So I've just got to do a little bit more work. So I reckon the bolt we need needs to be minimum length from the edge of the thread of 30mm. Found this, which is a 6mm diameter bolt. It's well used, but sufficient for my needs. So what we're going to do is cut the end off and weld it onto the end of the bolt, so it'll fit like this essentially. And I will cut the bolt off around here. Basically I need 30mm from the thread to the where it engages, so I only actually need a little bit of length of bolt. And we need to keep that length as short as we can because it'll be subject to a reasonable amount of side load when it's in operation. So we don't want it too long, or it'll tend to try and bend. So we've got the bolt set up on the welder ready. So cut the end off. We've just taken some of the bolt head off a little bit to allow a bit more room for welding. It's still all a little bit tight, to be honest, so it's going to be just a bit tricky not to get too much weld, but to get it nice and strong. You can also always grind a bit off afterwards, but obviously we don't want too much excess weld in the area, so it's going to be a little bit tricky to weld, but we'll see what happens. Got a small, I think it's a 2mm MMA welding rod. So here we have it. We've welded the extension on. It was a little bit tricky, but not as hard as I thought it might have been. So you see there's just a little bit of excess weld to remove with the grinder to make sure the bolt will fit into the hole. And also just tidy at the end of the thread to make sure it screws into the hole okay. So we'll just go and do that now. So we've cleaned up the the weld with the grinder, and now we're just going to use this triangular file just to make sure this first thread is nice and clean. So we have the tool completed now. So just cleaned up the thread at the end there. If you really want to, if your thread is quite badly damaged, you can remove the end few threads with the grinder. You don't actually need those. Anyway, what we can do, we can insert the new tool into the hole. And if the threads are cleaned up nicely, and it should screw in without too many problems. There we are. Now we can just use the socket just to screw it down that little further. You can see the slot isn't quite lined up, so you just have to turn the engine just around that fraction. Okay, so they're lined up now, so now we can fully engage the locking tool. Hopefully 6mm is the right size. There we are, screwing into the hole. Okay, looking good. Okay, it's going tight now, so I'm going to tighten it. Not too tight, but just fractionally, because obviously we're screwing into aluminium, so we don't want to overdo it. There we are, we have the crankshaft locked. So we have the locking tool in place, and we've got a nice long lever. And I'm going to give it a push to see if it'll come undone. Now, so with two hands it's just moved a fraction. Now I can get one hand, and there we go. Just to say, it's big enough, it's coming undone. So the locking tool has done the trick. So I've just come to set the timing up using my new timing tool, and I've actually realised now I've set all the timing in the correct position by the marks on the front there. So there's two slots on the flywheel, so the other slot is a little bit smaller. This is the slot that I designed the tool to fit, 6mm, and this one is a little bit narrower, so I'm just going to have to just use the grinder to reduce the diameter of my setting tool a little bit to fit in this slot here. So I've modified the timing tool with a very small taper on the end, so the end of the taper brings the diameter down to 4.5mm. Now it's wedged in the hole, so that securely holds the flywheel. It's not really the purpose of this video, but while I'm at it I'll just show you where the timing marks are for the 200tdi. So we have this pointer here, which points to the keyway. On this gear here we have a dot just there, which lines up with that arrow. And on the fuel injection pump there's a hole down there, which I'm going to find a drill bit to fit in there to lock the injection pump in the correct position.